All right, this is section 6.2. We are continuing on with our factoring. Now we've done the GCFs and we've done the grouping, and now we're going to look at some trinomials. Okay, we have two different types. 6.2 will be what I consider to, for lack of a better word, easy trinomials, and then the 6.3 will be the harder trinomials, and we'll use a different method on those. So we'll start out with the easy. Now the word trinomial means it's a three-termed polynomial, okay? So all trinomials that can be factored in this with this method have to be in this form. Okay? They have to have an x squared, an x, and no x. See how this one qualifies? X squared, x, no x. The a, the b, and the c are just numbers. They're the coefficients in front of the variables. Now all these easy trinomials means a is equal to 1. So there'll never be a number in front of this x squared term, which makes it actually quite simple to factor. Okay? So section 6.3, we're going to start throwing numbers in front of there, and then they're more difficult. So remember, we're trying to get the two binomials that would multiply to that. Okay, so here's your steps. The first thing that you want to do is you want to choose your product pair. Okay, so we know that all trinomials, let's just do something here. X plus 2, x minus 1. All right, remember that this was, it's this, right? X squared minus 1 plus 2 gives you positive 1 and then minus 2. Okay, so we've been given this and we want to get back to that. Okay, so what we're going to do is we're going to pick our, see how this is always binomial times binomial? So we're going to pick our product pairs down there. We're going to pick what our signs would be. And these are always set. Okay, so if I have a plus here and a plus there, then it's always x plus and x plus. Okay, if this is a positive and a positive, then these are positives and positives. So you might want to write that down somewhere. And I want to add to my middle term. Okay, so that's my first step, is to make my product pair here. Put my correct signs in. And then my next step is to make my factors of 10. Remember what factors are. What two numbers would multiply to a 10? Well, 1 times 10, 2 times 5. Those are my only factors that I have, 1, 2, 5, and 10. Okay? Now, if this is a bigger number, you're going to get a ton of these. Depends on the type of number. Since I want to add to my middle term, right? Because this is an addition, this back piece is an addition. I want to add to my middle term. I want to look at to see what my middle number is. It's a 7. Which pair adds to a 7? Well, 1 plus 10 is 11. That one won't work. But 2 plus 5 is 7. So this is your pair. And you're just going to slap them in here, and you're done. So to check, we refoil. X times x is x squared. X times a positive 5 is positive 5x. 2 times x is 2x. And 2 times 5 is 10. These can be combined. So we have x squared plus 7x plus 10. Check. All right? So let's try another one. We have a plus, plus. Plus, plus. Here a plus, there a plus. Everywhere a plus, plus. Sick. All right. And when these two are positives, then these two are positives. We are adding to the middle term. All right, so that's our start. Now I'm going to make a bunch of factors of 20. What do we have? We have 1 times 20. We have 2 times 10. We have 4 times 5. Do we have anything else? I don't think so. All right, we have to add to the middle term, which is a 12. Which pair adds to a 12? That pair. Now you can put the 2 here and the 10 there, or you can put the 10 there and the 2 there. It makes no difference whatsoever. Refoil to make sure you've got back what you started with. I'll leave you alone on that one. Okay. So now we have different signs. We're going to use the same method though. Okay. Now we have a minus and a plus. All right. That means these are both subtractions. Okay. This back piece right here is a positive, and so is this. So the signs have to be the same. This tells us whether they're negative or positive. All right. So since we have a negative middle term, we want to make these both negative, but they both have to be the same because this is a positive. So we're going to be adding to our middle term. We only have the one factor. Does 3 and 1 add to 4? Absolutely. Done. Okay, refoil. X squared. We have a minus x and a minus 3x for the minus 4x. Then we have the positive 3. Perfect. Okay. Same thing here. Same thing there. I'm not going to do all of these. They're all done the same way. All right, now we have minus minus. Slightly different, but nothing too drastic here. These are, like I said, I call these the easy trinomials. Now, I have a negative and a negative. So that means they have to be different. So one has to be positive and one has to be negative because this is a negative. Now I continue on. I'm going to make my factors of 120. What do I have here? Oh gosh, I have 1 times 120. I have 2 times 60. I have 3 times 40. I have 4 times 30. I have 5 times 24. Is that right? I better check. 5 times 24. Yep, okay. I have 6 times, what do I have? 6 times 20. 7 does not go in there. Does 8 go in there? Let's see, evenly. Yep, 8 and 15. 8 times 15. I've got, does 9, I doubt 9 goes in there. I don't think 7 goes in there either, no. I know 10 does, so 10 times 12. 11, 12 I already have. I think I'm done. Does anything else go in there? Maybe 15. Let's try 15. So you got to get all the combinations. 15 and 8, but I already have that one. All right. All right, so basically we're finished with our list, right? Nothing else goes in there. So now we have to say which pair, I'm going to have a pair that subtracts to 19. All right. Now before I was always adding to that middle number, right, on these. That's because that back piece was a positive. On both of these, I was always adding to that middle term. Here, I have to subtract to the middle term. So now I need a pair, a combination that subtracts to 19. Well, you know, you can go through the list if you want and pick out every single, you know, do every single subtraction. I mean, obviously it's this one, 24 and 5. 24 minus 5 is 19, correct? All right, so now we want a negative 19. So that would mean that I need, since my middle term is negative, I want the bigger number to go with the negative spot and the smaller number to go with the positive spot. Okay, because this can also be a positive. If this was a positive, then I'd want the 24 on this side with the positive and the smaller number with the negative. All right, so let's refoil. So we've got x squared, that's our first term. Then we've got negative 24x and a positive 5x. And 5 times 24 gives me the negative 120. This makes the negative 19. Check. All right. So when there's a subtraction in the back, that means that you have one of each. Then you make your list again, and this time you're going to be subtracting to that middle term, not adding. And then you have to put them in the right spots. Now, if you can't remember that the bigger number goes with, the sign or whatever, just throw them in and refoil, and if it doesn't work, then switch them around. You can always do it that way as well. So let's try one with a positive in the middle. This is done exactly the same. Okay, so we're going to have one of each, and it doesn't matter, to start out with, oops, those should be n's. Just pretend they're n's. I'm just so used to doing x's. All right. So now we make our list. We've got 1 times 60. We've got 2 times 30. What else do we have? We have 3 times 20. We have 4 times 15, I think. 5 times 12. 6 times 10. 7, 8, 9, 10. I think that's it. And again, we're subtracting. We have to subtract to this middle term of 11. Which pair subtracts to an 11? That one, right? 15 minus 4 gives 11. This time I have the positive 11, not a negative 11. Okay? So therefore I'd put the bigger number in with the positive and the smaller number in with the negative. X squared. We have a negative 4 and a positive 15 makes a positive 11. This is the negative 60. Right? Yes. I'm not going to check any of these. That one's the same. When are they prime? Look at this. I'm just trying to think ahead of time here. The trinomial is prime. What does that mean? Well, I don't know. Let's try it. Let's see if this is one. Okay, so we have, try to put the right letter in this time. A, right? I've got a negative in the back, so that's one of each. I'm going to make my list of what makes a 42. I've got 1 times 42. I've got 2 times 21. What else do I have? I have, does 3 go in there? Yes, it does. 3 times, is that 14? You can always use a calculator. I'm not real great at math in my head. I really am not. I never have been. 4 does not go in there. 5 does not go in there. We've got 6 times 7. What else do we have? 8, 9, 10, 11, 12, 14 goes in there. 15 won't. See, we might be done. We might be done with our list. So, what pair subtracts to a 2? Nothing. Therefore, it's prime. So if you make your complete list and nothing factors to this middle term, let me just check that. Yeah, I was just going to say I could have been missing one in here, but that's when the trinomial is prime, meaning you can't factor because nothing works. All right? There is no combination that subtracts to a 2. So that's what that means. How did I lose my... I think I lost my... you see that? I lost my numbers up here. Isn't that weird? There they are. All right, so I'm going to leave you alone on that one and that one. Okay, so nothing's new on those. So again, a nice short video, 15 minutes, bing bada boom. Write down your rules. You know, write down when we have these signs, we do this. When we have these signs, we do that. So that you have them all written down so that when you test, you've got it all laid out nice and neat right in front of you, okay? If I was teaching this in a face-to-face class, I would give you those notes to use on a test. So since you're online and you're kind of on your own, you have to make those notes yourself. Otherwise, I think, you know, these are pretty straightforward. So what we'll do is we'll look at the harder trinomials, and they're not hard. They're just not as easy as these in comparison. And we're going to be using the grouping technique. That's why we did the grouping technique last time, so that we can use it in the AC. It's called the AC method. Okay? So practice, practice, practice. I'll see you in a bit.